Okay. We are ready for the next section. And if you look on your syllabus, I've actually made this this is not letting me move up. There we go. I've actually split this section into two sections, two parts, so we're just covering this one section 3.2 today. Not because it's really hard, but to take a little bit of a break. So today's our little bit of a break day. The homework is not going to be as difficult, and will be a little bit, hopefully, easier. Okay, so the definitions that we have for x greater than 0, a bigger than 0, a not equal to 1, we have y equals to log base a of x, if and only if x equals a to the y. Notice what's happening here. The bases are the same. I want to change my ink color. We like black. There's black. The bases are the same. And the answer is what goes inside the logarithm. Over here, the y is what goes up into your exponent. So that's the relationship between the two of them. So as a function given by f of x equals log base a of x is called a logarithmic function with base a. There's all bunches of different logarithmic functions, just like there's a whole bunch of different exponential functions depending on the different base. So that's what's happening here. Let me show you why we care. Write the logarithmic equation in exponential form. So this one, it becomes 2 to the 8 equals x. The second one, it would be 3 to the y equals 2. So how would we write the last one? 7 to the negative 2 equals 1 over 49. Okay, you guys see the pattern? You have a whole bunch of those. We do those on our homework. Write the exponential equation in logarithmic form. So this is going to be log base 3 of y equals to x. What would we get for the second one? Log base what? Log base e, 4 equals x. And how about the third one? Log base 2 of x equals 3. And then the last one, log base x of b equals a. Do you guys see that pattern? Okay. Whole bunch of homework problems just like that. Yeah.
What was the log again?
What do you mean, what was the log again? What is it defined to be?
Yeah.
Log base a of x is equal to y if and only if a to the y equals x. That's the relationship between the two of them. Logarithms were actually originally figured out. The earliest history of the use of logarithms dates back to bankers in the Greek time period, trying to calculate banking accounts for people and computing interest and stuff like that. And the reason we call it logarithms is because they used sticks to calculate it, and they measured the sticks to various lengths, and they called it logs, hence logarithms is the translation we got when we translated it to English. They actually were not studied in depth until fairly recently, probably about 600 years ago, thereabouts, 500 to 600 years after the Renaissance. We had the logarithms being studied in depth, and the different bases and what the effect that had on the logarithms came into being. And at that point, we studied it to be able to multiply numbers together easily. The original basis of logarithms was before there was such a thing as a slide rule, but after the abacus. Abacus is a set of beads. You move beads over, count by tens on the abacus. The logarithms came after the abacus, before the slide rule. A slide rule is based on logarithms, and it's used predominantly for multiplication, not for addition. Multiplication and roots and trig functions all got put on slide rules. Okay, so that's the relationship between the two of them. Let's go on. So you guys get to write one. You have two problems right here. Log base 2 of x equals 4 in exponential form. And then 4 cubed equals 64 in logarithmic form. And don't simplify your answers. Just write it down. So what'd you get for the first one? 2 to the 4 equals x. Is that what everybody got? How about the second one? Yeah, log base 4, 64 equals 3. You just write them down. In other words, that should be your answers. No work. Okay. Use the definition of logarithmic functions to evaluate each logarithm at the indicated value. In other words, don't use your calculators. So for number 1 here, we're looking at log base 2 of 32. And I'm going to call it y, and I'm going to plug it in. Question?
I just want to see what sign. Command the minus button is to do this the log 2 of x.
Say that one more time.
So in web design, to get like log 2 of x there,
Mm-hmm.
to get the 2, you have to do command the minus button, and then it'll like you do it lower.
Okay.
I didn't see any way to.
There should be a way. I don't know. I haven't played with WebAssign to figure that part out yet. Yeah. No, you're running on a Mac. Most of you have Macs out. In fact, everybody. Is yours a Mac? We are Mac driven today, except for my lowly Windows.
I have Windows.
You have Windows? There we go. We have to hold up our own. Yeah. Okay, so log base 2, 32 equals y. I'm going to actually put this into the exponential form. So what is the exponential form going to be for that? 2 to the y equals 32. And we learned how to solve these yesterday. We have to write 32 as a power of 2. What power of 2 is that? Yeah, 2 to the 5th. So what is y equal to? 5. There's our answer for 1. Let's look at 2. We're looking at log base 3 of 1. I'm going to call that y. Put it in exponential form, and what do you get? 3 to the y equals 1. But how do you get 1 in terms of 3? Yeah, so that's 3 to the 0. So what is y equal to? 0. Let's look at number 3. We have log base 4 of 2. I'm going to call that y. Put it in exponential, and what do you get? Now I have to get 2 into powers of 4. What is 2 in comparison to 4? 2 squared is 4, right? So the square root of 4 is 2. Yeah. Or you could do it, I'll put an or right here, or you could do 2 squared to the y equals 2, and that gives you 2 to the 2y equals 2, or 2y equals 1, y equals 1/2. Over here, you would also get y equals to 1/2. You can do it either way. Okay? 2 ways for that problem. And then the last one, you have log base 10 of 1 over 100. Set that equal to y. Put it in exponential form. 10 to the y equals 1 over 100. What is 1 over 100 in terms of 10? 10 to the negative 2. So what is y equal to? Negative 2. Any questions on that? Can we do that on homework? Okay, the logarithmic function of base 10 is called the common logarithm, and it's usually written without a base. It's just log base 10. The logarithmic function with base e is called the natural log, and we write it ln, n for natural log. So whenever you see log without a number on it, then it's log base 10. If you see ln, it's a natural log. It means the same thing. It's still a logarithm. It's just telling you which base it has without actually writing it. Mathematicians get really lazy when they write things down, and so they take shortcuts. This is one of the shortcuts. Use a calculator to evaluate the function given by f of x equals log x at each value of x. So you're looking at log of 10. You guys have a calculator. It says use a calculator. This is where we have to understand something. How many log functions do you have on your calculator? The correct answer is 2. How can you tell? What's the difference? You should have a log with just log, that's log base 10. And you should have an ln, natural log. Those are your 2 logarithmic functions on your basic calculator. Those of you with a TI Inspire or one of those other calculators will actually have a different base on your calculator. However, you're not going to have that calculator on the test. Therefore, you're going to have to learn how to do it on these calculators too. So I'll get you a calculator to do the homework with when we're doing the homework in between here so that you can practice on it. But you do need to know that because someday your calculators will die and you'll need to calculate something and you'll need to know which log button to use. So this is log base 10. So I just write it as log of 10. That means you're going to ask your calculator to do log of 10. Most of you, that means you hit your log button and then you type 10 in and you hit enter. What does it give you when you do that? Should give you 1. Question?
If you do ln, then it gives you 0.30.
Yeah, that's a different logarithmic function.
Oh, yeah.
Has to be log base 10. What?
What base is that? It's different.
I didn't hear you.
What base is it? It's different.
That natural log ln is base e.
Oh.
So it's going to give you a different answer. It's going to be a steeper graph than, a shallower graph than log base 10. How about log base 10 of 1/2?
10 of 1/2.
Log base 10. Log of 1/2.
0.301.
Yeah, we'll go to 3 decimal places. Is that what everybody got? How about log of 2.5?
0.40.
Was it 3 decimals or not?
Or just rounded.
398. And what was the fourth one after the 398?
Oh, 397.
Oh, 398. Okay. Yeah, we'll keep it to 3 decimals. Not that it specifies it. Yeah.
So the log function always has 10 under it. We just don't see it.
Yes.
Okay. And then the ln
Always has an E.
under it.
Yep. And then here's a fun one. Does not exist. You can't plug in negative numbers into your logarithm. You can only plug in positive values into your logarithm. You cannot even plug in 0 into your logarithm. It has to be positive values. Notice that if you plug in fractional amounts, you get negative numbers. If you plug in anything bigger than 1, you're going to get positive numbers. Some will be smaller than 1, some will be bigger than 1, and some will be equal to 1. But it breaks at 1. The number 1 is going to be your break point for that. as long as your logarithm isn't a shifted function. Any questions on that? Can you do that on your homework? Okay, use a calculator to evaluate each of these, and this is a natural log function. So let's evaluate natural log of 2. 0.693. Natural log is 0.3. Do we expect that one to be positive or negative? Negative because it's smaller than 1. Natural log?
Yeah.
Negative 1.2. Okay. And then natural log of negative 1, what do we expect? Does not exist. Can't plug in negative numbers. And the natural log, now make sure that you put 1 plus the square root of 2 in parentheses so that it doesn't just do the natural log of 1 and then add the square root of 2 to it. So put that part in parentheses. 8, 8, 1. Okay. Do you see the difference in the two logarithms on your calculator? They are different. They give you different answers. So you have to use them when they're called for. If you see a log base e or a natural log, you're going to use the ln key. If you see a log base 10, you use the base 10 key on your calculator. Properties of logarithms. Whenever you plug in 1, you get 0. This is because if you write this in exponential form, a to the 0 equals 1. So natural log of 1, or log base anything of 1, is going to be 0. Because a to the 1 equals to a, if you put that in logarithmic form, you have a, log base a of a equals 1. In other words, when your exponent here is 1 and they're the same bases, that's what comes out. Same bases bring the exponent out. That's what this rule says. Bring the exponent out. Log base a of a to the x equals to x, and a to the log base a of x equals to x. Learn this one. Learn that rule. That's going to be your friend the rest of this chapter. Log base a of a to the x equals x, and a to the log base a of x equals to x. Same base here as the base inside the logarithm, and those two have to be the same for it to work. So those guys have to be the same. If log base a of x equals log base a of y, then x equals to y. This is our one-to-one property for logarithms. If log base a of x equals log base a of y, then x equals to y. In terms of natural logs, this means that the natural log of 1 is 0, the natural log of e is 1, and ln of e to the x brings the x down, and e to the ln of x brings the x down. And then our one-to-one property. Okay, so those properties you're going to want to know. They're just basic properties. Memorize them. Let's look at some examples here. Simplify each of the following. We'll start with number 1. We have log base 4 of 1. According to our previous slide, what is log base 4 of 1 equal to? If you plug in a 1 into your logarithm, you're going to get 0 for your answer. Doesn't matter what the base is. Let's look at number 2. Log base square root 7 of square root 7. Those two are the same, so our answer is going to be 1. Let's look at number 3. 6 to the log base 6 of 20. Those two are the same, so your answer is the value in your logarithm. That's 20. That's our rule 3. Let's look at 4. Natural log of 1 over e. Let me write that as the natural log of e to the minus 1. This is our 5th rule, our 4th rule. It says if your base is the same, and it is because this is a log base e of e to the minus 1, Your answer is just going to be your exponent. Your answer is your exponent. So in this case, it's just minus 1. Let's look at number 5. E to the natural log of 5. Well, that natural log is log base e. So those two are equal. What should our answer be? 5. Wait for the computer. There we go. That's supposed to be a 3. So natural log of 1. What is the natural log of 1 equal to? Zero. Natural log of 1 is 0. What is 0 divided by 3? And don't you love it when your computer plays a video? And 2 natural log of e. What is a natural log of e? 1. So this becomes 2 times 1. And what is 2 times 1? Well, how about 2? 5 for the couple up. You guys see how to use your properties? You have lots of problems like that. Just applying your properties to it. Which means you guys have a checkpoint exercise. Again, this one has no work either. You just write your answer down. You guys need to see the property screen. There you go. What did we get for an answer? 1. Everybody get one? All right. That's our solution page. Okay, so now use the one-to-one property to solve each equation. We're going to be solving these. These aren't bad either. You have log base 3 of x equals to log base 3 of 12. The bases are the same. So that tells you x has to be equal to 12. You set what's inside equal. Let's look at number 2. It gets a little bit harder. What is the base for these? Doesn't have one written down. 10. The base is 10. Is it the same base on both of them? Yes. So same base.
So 2x plus 1
Yep. 2x plus 1 equals 3x. How do you want to solve it? Subtract the 2x. You have 1 is equal to x. That looks like a solution to me. Yeah. You can't solve them then. You have to change your base to a common base. And then you can solve it. But I haven't given you the change of base formula yet. Yeah. That's the only way to solve it. You have to have it the same base to be able to solve it. And typically when you're trying to solve it, you will have the same base because you'll have done the computations all in the same base. If you're trying to set up a problem. Yeah. Okay, so you have log base 4 of something equals log base 4 of 10. Are the bases the same? Those are the same, so what do you do? Yep. Then I'm going to add this 6 to the other side, and I have x squared is equal to 16. What do we do then? Plus or minus the square root of 16, right? Which would be plus or minus 4. Now you have to be careful on these sometimes, because when you're solving them, you can get extraneous answers. None of these are actually extraneous answers because you can check them all. So let's go ahead and check them and see. Plugging in x equal to 12 is going to be okay. That's a positive value. That's what we're worried about. Are we ever plugging in a negative value? Plug in x equals to 1. And if you check this, you're going to have log of 2 times 1 plus 1. And you want to know, is that equal to log of 3 times 1? Well, what is 2 times 1 plus 1? So we have log 3. And what is 3 times 1? So I get the same on both sides. That one works. How about check it over here? And I'm going to check that x equals negative 4 first. So we have log base 4 of negative 4 squared minus 6. What is negative 4 squared? 16 minus 6? 10. Is that what you have on the other side of the equal sign? Yes. That one worked. So check x equals to 4. You're going to have log base 4 of 4 squared minus 6. What is 4 squared minus 6? What is 4 squared? 16 minus 6? 10. Is that the same? Yeah. They all work. We are going to actually get to the point where they don't all work. And then you have to be careful about what you tell me your answer is. So check them. You guys get to solve one. Hey, compare your answers with your friends or your enemies, whatever it be. Hopefully no enemies. No, kidding. Surprise.
Yeah.
Everybody got the same answers? And that is it for this set of slides. I thought I had one more. Okay, let me stop the recorder and you guys can start working on the homework.